Top of the morning to you nerds. Welcome back. This video is about elimination strategies. In the last video, and what you practiced on Khan, was the ability to combine two linear equations into one. This is going to be the strategy that allows you to do so, but in an effective manner where one of the variables, either the x's or the y's, will disappear. You're going to get a problem that looks like this. So why do we care about elimination? We are dealing with two linear equations that have a solution, which is the intersection of the two lines, which is represented by an ordered pair. When we're given the two equations, we can't tell just by looking at it where they intersect. So we need to figure out what the x equals and what the y equals. Elimination allows us, wow, I butchered that word. Elimination allows us to figure out what one variable equals. Therefore, we can now back solve it to figure out what the other variable equals by plugging it into either one of the equations. Either one will work. All right, so there's two things we're going to need to do to be able to use the elimination method. One, we're going to be multiplying. We're going to be distributing some integer to the entire equation. And then we're going to be either adding or subtracting the equations together. So here, right behind me, is what one of the questions on the Khan practice activity is going to look like. They're going to ask you which one of the strategies would eliminate a variable in the system of equations. And it's going to provide you with two equations. And then there's going to be three multiple choice options that describe methods that you could use that would maybe eliminate it or maybe not. You have to figure out which one actually would cancel out either the x or the y if you follow the directions that they gave you. So we have two linear equations and both have two variables. Both have x terms and both have y terms. So we have two options in solving this really. We got to figure out what we could do to this equation to make the x's disappear, or what we could do to this equation to make the y's disappear. Now, the thought process is really this. We have the smaller number and the larger number. How can we change -1 into a number that when we add it with +7, that it would be equal to 0? How would it disappear? How would it be eliminated? What could we do to this entire thing? Because whatever we do to one term, we have to do to all the terms to keep them balanced. So what could we do to -1 to make it into something that when we added it to 7, it would disappear? What's the opposite of +7 is what you need to think about. -7. What's 7 minus 7? It's 0. Or opposite way of thinking about it, what is 7 plus -7? Same thing, 0. So if we multiply this whole thing by 7, we will distribute the 7 to all three terms because we got to keep balanced. What would we get? Let's do so. I'll show you. What's 7 times -x? -7x. What is 7 times 6y? That'd be 42y. And what is 7 times 8? 56. If we did 7x plus -7x or 7x minus 7x, this would just completely disappear, leaving us with just a y and an integer where we could find out what the y coordinate for our answer is, what our solution is. The good news is this week you don't have to do that. It's just being able to realize what you would have to do to set it up. Next week is when we're going to do the actual elimination process and find the ordered pair, which is our solution. But this week, you just have to figure out what we could do to eliminate the x. Let's take a second to look at what we could do to eliminate the y, just so you know that you can do something to either equation to manipulate it in a way that would make it, I'm rambling, just let me show you. All right, for the y, let's look at our two options. We have 6y, +6y on the top equation, and -1y on the bottom of equation. Which one is the one we should manipulate? Which one should we multiply by something? Can we multiply 6 by any positive integer that is going to make it equal to -1? We'd have to do a fraction, and multiplying all the rest by fractions gets messy. I think it's easier to multiply the smaller number by the whole number and bring it up to it. And therefore, if you're multiplying everything by an integer, you're going to get integers. You're not going to have any messy fractions to deal with. So what can we multiply -1 by to be the opposite of +6, meaning -6? We multiply -1 by 6, making it -6. 6 minus 6 equals 0. That was wordy. Whatever. I'll show you. Multiply all of them by 6, so I must distribute equally. 6 times 7, 42. 6 times negative 1 is negative 6y. And 6 times negative 2, negative 12. Now, if this is next week, then you'd have to combine these two equations through addition. We'd have negative 1 plus 42, 6 plus negative 6, which is nothing, it cancels out, which would be the whole point of it. Then we could solve for x, and then back solve in, take our x value, plug it in here, and figure out what y equals. But you get to relax for a week. Start next week, that's what you're gonna be doing. I promise you, once you guys get the hang of it, you won't feel mentally vexed. It'll be nice and quick. If you do need help, come visit my office hours or send me a message on Remind. Love you, miss you, nerds.